use as many radials as you can, as long as you can, and keep them as straight and long as possible, in as many directions as you can spread them out even. And then when you're done with it, you've done the best you can do. And then you don't have to worry about it.
Great. I think we got time for one more question. Maybe?
Last gentleman over here.
Oh, over there? Okay.
You already touched on it, Tom, about elevated radials and ground-mounted radials. But I'm a proponent of elevated radials above amper height. And I wonder, is there any way to determine, is that better? Two radials that's elevated versus maybe 10 or 20 on the ground for 160?
Every time I've measured it and compared systems like that, 4 radials elevated, 2 radial elevated are fairly lossy when I've measured it. They really don't even work well on ground planes way up in the air. The 4 elevated radials are pretty good. They get you up close to what a full-size system is. But everybody has to remember, here's the mistake we make. We think because the FCC, here's what happened. The FCC told broadcast stations, if you use 120 quarter-wave radials, we won't require you to go out and prove that your ground system is good. There isn't anything that says you have to have 120 radials as a perfect ground system. That whole business came from the FCC saying, if you overkill something a ridiculous amount, then we won't make you prove that you did a good job. and so HamJam and everybody all along have said that a perfect ground is 120 quarter-wave radials, and there's no truth to that at all. If you cut half those radials off, if you go around with wire cutters and cut half, every other radial you cut off, you won't see a field strength change at all on it. And you can come down, as a general rule, depends on the soil, you can come down to like 30 radials. And the field strength is just barely changing. So when we compare these systems and we compare the amount of work, we really have to think about this a little bit. And the reason why I use buried radials or underground radials is because I have a lot of antennas. I don't want 4 or 10 or 15 radials up in the air 6 feet off the ground on 10 or 15 different antennas and have to maintain all that, and I don't get lightning protection with those things up in the air. If I just put all that stuff down on the ground, maybe I have to use 2 or 3 times as much wire when it's down on the ground, but it's on the ground, it's out of sight, it's out of mind, and I get lightning protection. So it also isn't resonant, so I can use it on multiple bands with the same system. I don't need a system for every band. So it's all a lot of it's a lot of what we like and what we don't like. We all want minimum work and maximum return, but sometimes we compare it to goals that are set artificially high, like 120 radials.
And one more question.
Well, his question is why a beverage is better over lossy ground than highly conductive ground? Okay. That's a difficult question because it's kind of involved. Remember how a dipole, I mentioned earlier, a dipole has a vertical response off the end. A beverage is a little bit like a lot of things. It's a little bit like a dipole antenna off the end being vertically polarized. There's a little bit of that effect. There's another effect where the lossy earth, the poor dielectric of the earth slows the wave down and tilts the wave. And so the wave coming in now is no longer horizontally polarized. bridge over a perfect ground, what you really build is you build a transmission line. You build a wire over a ground plane, and if that's a perfect ground plane, you go out and terminate it, you pretty much just have a feed line, and the sensitivity